How have programming languages improved to avoid off-by-one loop errors? Imagine writing a simple loop to print numbers from 0 to 9. It sounds straightforward, but a tiny mistake in the boundary can cause the loop to run one time too many or too few. That's what off-by-one errors are all about. Over the years, programming languages have added features to help prevent these mistakes, making code more reliable and easier to understand. One big change is the use of half-open intervals in loop ranges. Instead of writing loops that go from 0 to the total number -1, many languages now encourage or enforce writing from 0 up to but not including the total. For example, instead of writing for I equals 0 to n-1, you write from 0 to n, excluding n. This way, it's clear where the loop starts and ends, reducing confusion about whether the last element is included or not. Another improvement is the standardization of zero-based indexing. Most modern languages like Python, Java, and C use zero-based indexing for arrays and collections. This means the first element is at position 0, which aligns perfectly with half-open interval loops. While zero-based indexing can cause initial mistakes, once understood, it simplifies boundary calculations and makes loops more predictable. Languages have also become stricter with loop condition syntax. Instead of using less than or equal to operators interchangeably, many now promote the use of strict inequalities. For example, using less than instead of less than or equal to in loop conditions helps prevent accidental extra iterations. This small change makes a big difference in avoiding off-by-one errors. Enhanced type systems and compiler warnings are another step forward. Some languages now include tools that analyze your code before it runs. These static analysis tools can detect potential boundary issues or array access errors and warn you early. This way, you catch mistakes during development, not after deployment. Built-in range functions and collection APIs also help. Languages like Python have a range function that clearly defines start and stop points. Rust has range syntax that makes iteration boundaries explicit. These features remove the need for manual boundary calculations, which are often the source of off-by-one mistakes. Debugging and testing support has improved as well. Modern development environments encourage writing tests that check boundary cases. For example, testing the first and last elements of a collection can reveal off-by-one errors quickly. Debuggers also let you step through loops to see exactly where they might go wrong. Finally, better documentation and coding standards promote clarity. Developers are encouraged to write descriptive variable names and document loop boundaries explicitly. Following consistent coding styles reduces misunderstandings that can lead to off-by-one errors. All these improvements make writing correct loops easier and safer. When debugging, always double-check your loop boundaries, consider using half-open intervals, and take advantage of language features like range types and compiler warnings. These tools help catch errors early and keep your code running smoothly.